Welcome to another Earth Engine tutorial. In this video, we are going to talk about how to do supervised classification in Google Earth Engine. In the previous tutorial, we already talked about how to do unsupervised. So today we will talk about supervised classification. Let's get started. First, you need to install the Gmap Python package. You can follow my first tutorial how to install the package, or you can go to the installation section and follow through the steps to install the package. After that, you can clone the GitHub repo, or you can go to the examples folder and then notebooks, and it will be number 32. So this is the tutorial I'm going to use today. You can click the raw button, and then from there right click save as, and then you can save it to your user directory. I'm going to save this one to my downloads folder and then hit save. Let's go back. Once you have the package installed and also you have the notebook examples, and then you can open your terminal, and then you can start doing coding. So first of all, you can use conda activate and Gmap, then Jupyter Notebook, and then you can open the browser. Okay, let's maximize, and I'm going to go to the download folder, open the notebook. So this will be the one that we're going to go through step by step in this tutorial. And first of all, I would like you to point out some of the algorithms right now available in Google Earth Engine, some of the supervised classification. If you see from the list here, right, you can have decision tree, you can also have support vector machine, and also here SMITE CAT. CAT stands for classification and regression tree. We also have the other one, random forest. Okay, so there are a couple of algorithms that you can try out, but for today we're going to just use the simple one here called Smile Cut. Okay, and I'm going to show you how to do this one later. So here you have some description how to do supervised classification in Earth Engine, and there are a couple of steps. So first of all, you need to collect the training data, and then make sure you have the data label so that you already have a class. Different from the unsupervised, you will need to have a label data set, otherwise it's not supervised. Okay, and then you can initiate a classifier. For example, these are all the classifiers, so we're going to use, for example, the Smile Cut, and then we can train the classifier using the training data and then classification, and after that we can do the mapping. And for the last step here, estimate classification error. We are not going to talk about this one in this tutorial. I might make another follow-up tutorial how to do accuracy assessment, but for today we're just going to focus on the first 4 steps in here. Okay, so now let's go through step by step how to do this one in Earth Engine. First, let's import the library, and then we can create an interactive map, and after that we can add some data. So this is the same step as what we did in the previous tutorial, how to find the data. So in this tutorial I'm going to use the same location. I'm going to use the for example, this point location is around San Francisco, California, and I'm using this point, and we are going to use the Landsat 8 surface reflectance data. So this is the entire image collection for Landsat 8 surface reflectance. Then we filter by boundary, so any images intersecting this point, we're going to get those images, and also going to filter by dates using the 2016. So any imagery acquired for this location during the 2016, and then we're going to sort by cloud cover, and you just get the first one because you might have a bunch of images. We're just going to get the this cloud coverage image, and then we select the band. So we want band 1 to band 7. Okay, so once we have this image, then it's supposed to be a high quality image, and after we can do some visualization, how to visualize the map using band 5, 4, and 3. So this is first color composite, and then we display the map. So so right away we have the Landsat imagery for this location. So next we might want to check, for example, when was this imagery acquired. So you can use, for example, image.get, and this is the properties. So once you get the date, you can reformatting using the year, month, and date, right? So this imagery was acquired in 2016, November 18. We can also check the cloud cover because we already saw this one using cloud cover, so it should be pretty low. If you take a look, okay, it's 0.08, so that means this image is cloud cover is 8%. So you might not see clearly. Okay, so these are some of the clouds within this imagery. It's anyway, it's a good quality imagery. Once we have the imagery, and this is the one we're going to use for supervised classification. Before we can do the classification, we need to have the label, right? We need to have training data set. So how can we get the training data set? And because this location is in the US, we're going to use the NALCD. So the reason that earlier I used the imagery from 2016, because I know in 2016 we have the NALCD 2016, so we can actually use the NALCD 2016 to get some label data set. So what we're doing here, if you look at the NALCD, right? So this is the legend for the NALCD. So each value represents one class. And so first we're going to grab the NALCD lane cover, so the NALCD 2016, and we're going to get the lane cover band. Once we get the NALCD, so this one is for the entire US, then we clip this one to the image geometry. The image is the one, the Landsat 8. Okay, so we don't need the entire lens NALCD. We just need that one for this portion, right? So we use the clip function to clip the imagery, and then we add the NALCD to the map, and then we can hit run. Take a look. Now we have the NALCD. So if you compare this one here to the Landsat 8, right? So the NALCD, I'm not quite sure exactly which image was used to classify and get the final product of this one, but we can simply use this one just as a proxy because we need some training data and we need the label. So you can go out to the field to collect the training data, or you can use some existing data. So we assume that we already have the training data, so we're going to get something from this NALCD. So next, let's see how we can get the training data. So if you see from this one, the NALCD here, it doesn't cover the ocean, so it only covers the land area and the boundary surrounding the coastal area. So what we're going to do is that we're going to generate a bunch of random points within this NALCD, and then we can get the label. Like basically each point we're going to have the class belongs to which class. So 1 second, my mouse is not working, so let me plug in. Okay, and so what we are going to do is here to execute this portion. Let me execute this one first, and just to show you what I meant. So we have the NALCD, right? So we're going to sample the NALCD, and based on the image geometry. So the image geometry is the entire Landsat 8. And let me turn off this one. So this is the training data set. If you zoom in, you should be able to see those points. So basically we generate in here 5,000 random points within this area, and we also show the geometry. Otherwise, it will be just a feature collection without geometry. So we show the geometry and then we add the points. So now we can, for example, print out how many points actually were generated. You see here 3,640 points, but originally we said 5,000. So the reason for this is because some of the no data area here. So when a point intersect the no data area, it was eliminated. So that's why we only get 3,600 points. So if you want really 5,000 points, this one might need to be larger. And then we can take a look at, for example, just the first point. So we have 3,600 training points, and this is what it looks like. So you have a property called lane cover 31, right? For example, lane cover 31. If you want, you can go back to see here. Okay, barren length is the class 31. So this is the training data that we have, and now we have the label. So then we can use to train the classifier, because we already have the training data set. The training data set basically is just points, and then with the points with one attribute, it's called lane cover 31. So if you have another point, you might have another lane cover. The next step is to train the classifier. So how do we train the classifier? Because in this tutorial, we're going to classify the Landsat 8 imagery, right? So it has 7 spectral bands, so we're going to use these 7 spectral bands, and also the label. So essentially at the end, how the classifier, you need to have the value for this 7 spectral band, but you also need to have a class, so basically a label, right? So at the end, it's basically a vector with 8 values. Each location you want to have 8 values. 7 values represent the original data, and the last value represent the class. So what we need to do is the original image, and then you select those 7 spectral bands. Then we use the sample region. Okay, so the collection, so we're going to use the points, right? So the points come from here that we already generated, and then the property, we're going to keep this label. So the label, that means it's the lane cover label, right? So the lane cover label that we use in here, and then we want to use the scale number 30 meter, right? So the last step is that we want to train the classifier. So in this tutorial, we use the smile cut, okay, classification and regression tree. So this is the classifier, and then we need to train the classifier using the training data come from here. So this is the training data that we generated, and then the label. So the label is lane cover, how many spectral bands, right? And let's take a look. So after that, we can take a look at the training data. That's just the first point, right? So because we have 3,640 points, so let's look at the first point, first training data, and you will see from these properties in here, now the training data include 8 spectral bands, right? B1, this is the value, and then B2, this is the value. And lastly, you have the lane cover. So this is the original value, and this is the classification, right? So if a pixel is kind of close to the values like this, most likely the lane cover type will be 31. And if you change to the other one, it's going to change accordingly. So at the end, this is what it's going to look like. Basically, the training data set is just like a spreadsheet, and they have 7 columns represent the values, and also you have another column represent the class. So this is what the classifier is trained based on. Once we have the classifier, then we can go ahead to create classify the image. So image, select dot bands, and so we use 7 spectral bands. All we need to do is just use the classify function, and then passing the classifier. So the classifier is from the steps in here. Then you have the results, right? So once you have the result, we can add the result to the map. But keep that in mind, in here we only use the random visualizer. So basically, we assign a random color to each class, right? So you can fit in this one. So now this is the classification result for this imagery, for this lens imagery. And we train this one. You can also take a look at the NLCD. So if you zoom in, and then you can open the inspector. So I'm going to click this one and take a look. So the lens cover, the original lens data, it was class 11. So now in the classification is also 11. The color might look different, but the value might be the same. So also 24, that means it is correctly predicted. And 23, let's see if we can find any data different. Okay, this one is different. So the it's supposed to be 23, but this one was 82. So it might be false classification. We don't know yet, but just show you like how you can check the results. So next, let's see how we can render the map, because this is like random color, not very useful. So we can actually change the color. How do we do that? Because earlier from the NLCD, right, you will see here, this is the traditional color being used. We might also want to use the same color scheme, so it's easier to compare. So first, in order to do that, we need to set some image properties. So the image need to have these two, the lane cover class values and also the lane cover class palette. So this is basically the name of the the image band, because this one here is called lane cover a classification. So the lane cover is actually from the NLCD. Okay, so from the NLCD, if you want to see where does it come from, you can go to the NLCD Earth Engine dataset page, and if you go to the image properties, and this is what those come from. Okay, so the band, because we only use the lane cover spectral band, lane cover band, and then the image property is that the name of the band and also underscore class names. So if you have a band called lane cover, if you have these two in the image property, when you add the image to the map, it will based on this color palette that you're using here. And so for our classification result, it's actually called classification. So you need to have classification underscore class names. And so this is what we are trying to do here in the last step. Okay, so let's take a look at this one. For the NLCD, right, if you get the values from 11 all the way to 95, and this is the lane cover class palette. Okay, so these are all the color corresponding to each class. So all we need to do is that for the result we want to set, so this is the name of the band within this image. So we're going to set these class values the same as this one, right, as the NLCD. And also the class palette, we're going to use the same as this one. So once you need to make sure that you assign this one to a new variable, right? And this is the original classification result. So we use the one, we set this property, assign to a new variable, and then we use this new variable, set another property, assign to another variable. Okay, so this is the last one we're going to use, and then we can add the map. So now you see this one, you see the familiar color, like it's just very similar to the NLCD. So if you see from here, the result looks pretty close. It's not exactly the same. This what we expect, right? Because it's a different image. It is not the same image that being used to do the NLCD classification. And then after that, you can take a look at the result, or you can also visualize the result to change the opacity. So if you want, you can run this one, and then you can change the opacity, right? Compare this one to the original data or the NLCD or the original lens set, right? So if you zoom in, and we can change the opacity from 0 to 1, right? And you can take a look at the compared result to visualize how accurate is the classification result. It's not perfect, okay? So this tutorial is not designed to do perfect classification. I'm just designed to show you the overall workflow, how to do supervised classification in Google's engine. So once we visualize the results, we can also add a legend to the map, okay? So in the GE map package, we have a function called add legend. And then if you use the built-in legend NLCD, you want to add this one to here. So, and if you maximize, and we see from this one here, if you zoom in, now you can see all the color. So you can click, you can open the inspector, and then if you click, so NLCD, the last one. So this is what we should look at. So classification 11. 11, it means open water, right? And if you zoom into any location, and if you click one specific location, so here 24, right? So 24 means develop high intensity. So this is the final result, 24, and the original NLCD actually is 23. Okay, so develop medium intensity, so it's pretty close, no 100%. So we can change the other one, like 42, 44, 42, right? That means it's perfect. Anyway, you can explore, but keep in mind, you can, once you train the classifier, you can classify any images. You don't have to classify within the same location here. You can classify the image for other location, or for the entire US, or for the entire globe. So it's up to you where you want to apply your results. Lastly, once we have this map image classified, we might want to export the results. So in here, you can, for example, you can export the map to your local computer, or you can also export the map to Google Drive. So I'm going to show you two ways. The GE map package has two functions. Export image, that means we want to export this one to our local computer. And you see here, make sure that you change the scale original, because the Landsat data is 30 meter resolution. I'm using 900 just to make it faster to demonstrate what it is. So if you go to here, now you see this one is lane cover, right? And then you can use QGIS or any GIS software to open the imagery. So if you come to here, and then just drag, now you have the result. Okay, so this is 900 meter resolution, so it's not very good, but you can export the 30 meter original. But if you use 30 meter, sometimes the memory might be exceeded, so you might not be able to do this one. But you can also export this one to your Google Drive. Okay, and again, set the scale, set the folder. If you don't set this one by default, it's being exported to your user directory of your Google Drive, and this is the name of the file. So you can take a look, export, and then it's being automated. Okay, that's pretty much for this tutorial. If you enjoyed this video, please consider hitting the like button and subscribe to my channel. You can also leave comments down below. Hope to see you in my next video. Take care. Bye bye.